This theorem is angles subtended by a chord or arc at the circumference of a circle on the same side of the chord are equal. First, let's understand what is a chord, what is arc, and what is a circumference. Actually, a chord in over a straight line se join 2 points on a circle. Let's say can a straight line in this way. Se join 2 points on a circle. So this line represents a chord. Le ge ka ba e nyane in this way, but ke chord. For as long as it is straight line and then se join 2 points on a circle, e re la gore ke chord. And then arc, actual arc in over any part of the circle. Let's say this part re bitša ke arc. Le ge ka ba e kgolo but e sa le arc, for as long as le any part ya circle, so re bitša ke arc. And then circumference actually re no bolela ka the outer boundary ya a circle, re no bolela ka mo godimo ga circle, because actually a circumference in over a distance around the circle. So ge re bolela ka a circumference re no bolela ka the outer boundary. And then now let's say re na le chord, and then let's say this chord ke AB. Now this chord is subtend angle at the circumference. Re no rela gore e create angle on the circumference. And then let's say this same chord ya AB e create another angle at the circumference. For the reason ya gore this chord e created this angle, and then at the same time ya create this angle, re la gore these angles di a lekana based on this theorem. Ge e le gore this angle ke 30, re la gore this angle ke 30. Le ge o ka ba le another angle, these angles di a lekana. This is because this angle ge re create from this same chord. And then lemoga something, these angles ka fela ga tsona di on the same side, because o ka kgona bona gore ka fela di ka mo godimo di on the same side. So this means ge o ka create angle in this way from this same chord ya ba ka mo fase, this angle e ka se lekane le this angle because ga di on the same side. This theorem e re di tshwanetse di be on the same side. And then ge re prove re šomiša this theorem re re angle in the same segment. Now we explain this theorem re šomiša chord. Let's say now re šomiša arc. Remember arc in over any part of the circle, so more na le arc. And then let's say this arc e create angle. The key theme mo gore this arc e create this angle, and then that same arc e create this angle. So it's really the same thing. Re la gore this angle and this angle di a lekana because di created ke the same arc. That is why this theorem is angles subtended by a chord or arc at the circumference of a circle on the same side of the chord are equal. So this means this angle and this angle di a lekana. Ge o ka lebelela mo re sana le the same thing, ke nyaka go bontsha something. Ge o ka lebelela mo re na le arc, remember arc in over any part of the circle. So this arc e create this angle, and then at the same time this same arc e create this angle. So re la gore this angle and this angle di a lekana. Therefore in conclusion re la gore ge o ka ba le something like this one, re la gore this angle and this angle di a lekana, and then this angle and this angle di a lekana. So ge e le gore mo ke 20 e rela gore le mo ke 20, and then ge e le gore mo ke 10 e rela gore le mo ke 10. So every time o ka bona something like a butterfly, o tlo tshwana ka gore go gopole ka this theorem. And then now more nyaka prove gore indeed this angle and this angle di a lekana because di created ke the same chord. Based on everything e le gore e be re claima gore this angle and this angle di a lekana because of this same chord or same arc. So ge re tlo prove this theorem, re tlo shumisha theorem number 2. Ge e le gore you don't remember theorem number 2, o tlo tshwanela go check theorem number 2 first, because re tlo shumisha theorem number 2. This one is very easy and straightforward because re tlo shumisha another theorem go prove this theorem, and then this theorem o tshwanetse go prove for exam purpose. Mo re na le theorem number 2. This theorem e re the angle subtended by an arc or a chord at the center of the circle is double the size of the angle subtended by the same arc at the circumference of the circle. Let's say more na le a chord in this way or arc, so it doesn't matter either ke chord or ke arc. Let's say re na le chord in this way, and then this chord is subtend this angle at the center, and then at the same time ya subtend this angle. E rela gore this angle mo center it will be 2 times this angle at the circumference. So ke theorem number 2. Re tlo shumisha this theorem go prove this one. So the first thing we tlo dira construction, ke rile join AO and DO. So ke tlo construct this line ya center it will be AO, and then ka construct DO. And then now because ke constructed this line, ke tlo shumisha that theorem. And then now lemoga something, this chord ya AD is subtend at the center, and then this same chord ya subtend at the circumference. I rela gore this angle ke 2 times this one. So based on that second theorem, I rela gore A angle OD is equals to 2A angle CD. I rela gore this angle is 2 times this one. And then re fa reasoning re angle at center is equals to 2 times angle at circumference. And then now we do the same thing. O ka kgona bona gore this same chord is subtend at the center, and then again that same chord ya subtend this angle. So e rela gore A angle OD e lekana le 2A angle BD. Same reason, angle at center is equals to 2 times angle at circumference. And then now because more na le A angle OD, and then arna le A angle OD, which is the same thing, e rela gore 2A angle CD lekana le 2A angle BD because ke AOD AOD, so ke ntho e tee. Therefore go to substitute 2A angle CD ka re lekana le 2A angle BD, and then from here nka no divide both sides ka 2 because kaofela di na le 2, therefore e rela gore a angle CD e lekana le a angle BD. So ke provile a angle CD e lekana le a angle BD, which is this one. So the first thing o tshwanetse go gopole ka the second theorem, and then o šomiše that second theorem go kry this one. Very easy and straightforward. So ke prove rena in this way. And then o tshwanetse o tseba gore le ge ba se ba go fa a chord, ba go file circle in this way, re dira the same thing. O tlo no constructa a line ya joiner center ya gago, and then we apply everything ile re apply. And then it's always important gore o ngwale construction, but make sure ya gore ge ile gore circle ya gago, let's say center ya gago ba e name ile gore ke M, so o šomiše those letters o file o tsona, but construction e na le M mark o tshwanetse o tsebe. And then those things tša gore given with whatever, it's not important go prove. Nna ke ge ke go bontšha fela gore re approve what and what. So RTP, remember gore e no rela gore required to prove, but when in your exam the first thing to do construction, and then we join whatever we join now, and then we prove. So it's the same thing. And then more normally a similar practice problem. This question, find the sizes of the unknown angles. The first thing, o ka bona a butterfly. And then what's about o bona a butterfly, o gopola ka angles in the same segment. More normally arc. And then this arc is subtended this angle. And then at the same time, this arc is subtended this angle. This means these angles they are lekana. And therefore we rela gore B is equals to 42 degrees. And then reason ke angles in same segment. And then again ge ile gore this is my arc, o ka kgona bona gore this same arc e extend this angle, and then that same arc ya extend this angle. Therefore o rela gore this angle and this angle di a lekana, same reason, angle in same segment. Therefore rela gore A is equals to 31 degrees, and then the reason ke angle in same segment. So every time ge o bona o na le a butterfly, something like this one, gopola ka angle in the same segment. What's about this angle and this angle di a lekana, and then this one and this one di a lekana. So ke answer ya rena in this way. And then mo ge o ka lebelela this question, o ka kgona bona gore re na le a chord, and then that chord e create the angles on the circumference. Mo re na le chord, this chord e create angle on the circumference, and then at the same time e create angle. So e rela gore angle K is equals to 44 degrees, and then the reason ke angles in same segment. So ke answer ya rena in this way. Ge o ka lebella this one, o ka kgona bona gore re sa na the same shape. Re tseba gore this angle e tlo lekana le this angle, and then this angle e tlo lekana le this angle, but now re nyaka x and y. Ge o ka lebella this question, the easiest way ya re kgona go find out x and y, lemoga gore o na le parallel lines. The moment ba fa parallel lines, era gore o tlo tshwanela gore o dire something se lore se related to parallel lines. So o ka kgona lemoga gore this angle and this angle ke alternate angles. Now rela gore y is equals to 24 degrees, alternate angles. And then because re tseba gore this angle e lekana le this one, re la gore it will be very easy. X is equals to y, which is equals to 24 degrees. The reason, angles in same segment. So ke answer ya rena in this way. The first thing, try always try to analyze the question ya gago, and then whatever the information about fa yona e rela re shumisha. Ga feel the parallel line, think about parallel lines, and then afterwards o lebelele the easiest one e le gore solve, and then afterwards o conclude by solving whatever you nyakago. So ke answer ya rena anyway. And then more a converse. Converse actually is like a reverse. This converse area, if a line segment subtends equal angles at two other points on the same side of the line, these 4 points lie on a circle. Let's say more a line segment AB, this one. If this line it can create the angles JPD, and then those angles they are like, so re tlo conclude our these points the on a circle, meaning re ka create a circle, ra ba le something like this one. Remember gore previously be re ge re na le circle re prove gore this angle and this angle di a lekana. So now ba tla ba go file ABCD, something like this one in your exam, but prove gore ABCD lie on a circle. So ge o ka re o na le a line e le gore create these two angles, wa kgona go ka prove gore this angle and this angle di a lekana. So e rela gore these 4 points di lie on a circle. Sometimes ba bitša gore ke a cyclic quadrilateral. Remember gore quadrilateral e no ba 4-sided figure, so re na le 1 2 3 4. So concyclic quadrilateral, so in order this quadrilateral a lie on a circle. The key thing we're not going to prove this angle and this angle they are lekana, and then o tla bo prove le rona le concyclic, and then you prove o shumisha this converse o prove these 4 points they lie on a circle. The reason it over this one, line segment subtend equal angles on the same side, so it will be a reasoning. So you know about nakamhoki. And then now more a related question. This question prove that PQRS is a cyclic chord. This means we can prove these 4 points they lie on a circle. So the moment I get something like a butterfly, and then this question cyclic, ke gopola ka that theorem ya angle in the same segment ye very prove. So ke thoma go gopola gore this angle and this angle di tshwanetse di lekane, or this angle and this angle di tshwanetse di lekane. So ge nka kgona go prove gore at least this angle and this angle di a lekana, or this angle and this angle di a lekana, e ra gore ke tla be ke provile gore these 4 points di lie on a cyclic. So you know a line here, remember, because this line it creates this angle here P and S, so it's the same thing, don't be confused. Now this question you can find this angle ya M1, o tlo kgona go create this angle ya S, because we find the angle M1 go very easy because re na le adjacent angles on a line. Now nkare 110 plus angle M1 is equals to 180 degrees. The reason key adjacent angles on a line. And then from here, we'll find angle M1 over 180 minus 110, over 70. So really M1. And then now because canale M1, MRS kibona as a triangle, and then go find S over very easy and straightforward. Therefore kitori angle M1 plus angle R plus angle S is equals to 180 degrees angles of triangle. And then from here go vale 70 plus 60 plus angle S is equals to 180. Therefore, if we solve angle S, angle S is equals to 50. And then for the reason our this angle and this angle dialekan error uprovil. Therefore, angle P is equals to angle S. And then in conclusion, therefore PQRS is a cyclic. And then for that same reason, line segment subtend equal angles on the same side. So always offer a reason, because how can offer a reason or lose a mark? So make sure you offer a reason. So anyway, reprove it in that way. And then morally a corollary. Actually a corollary no statement is already proven. This corollary equal chords subtends equal angles at circumference. Let's say you need the chord in this way. This chord here AB EF. So if these chords this subtends are equal angle, meaning wherever moody create out the angles, those angles this angle this angle. The reason equal chords subtends equal angles. So it doesn't matter if subtends are those angles okay. The key thing on chord dialekan. So and then there is no need to reprove in your exam. We're not trying to know fail. And then moki the related example. The chord. And then what feel this chord and this chord dialekan. And then this chord is subtended at the circumference. And then the same as this chord is subtended at the circumference. So the angles down at the so our answer x is equals to 40. And then the reason equal chords subtends equal angles. So and then morally a converse that corollary. This one the angles jeopardy on a circumference. Those angles radicalican the chord create those angles because this angle here D, this angle here C, the on the circumference, and then these angles dialekan. That chord create those angles dialekan. This angle D created this chord EF, and then this angle here C created chord AB. So AB EF. This is because the angles down dialekan. So the converse in our reverse that corollary equal chords subtends equal angles. And then morally another corollary. Remember that first corollary equal chords subtends equal angles at the circumference. But now this one equal chords subtends equal angles at the center of a circle. The chord in this case chord AB CD. Indeed these chords subtends at the center. Those angles this angle this angle actually not the previous one, but now the only difference is subtends at the center, meaning former angle more center this angle and this angle so the easy and straightforward. The key thing in your exam, just for in case even though they are very rare, but nonetheless make sure you understand everything for your exam. Oscar, this one I pay it because one day you will be disappointed.